Okay, section 5.4 is about indefinite integrals, which we've seen before. They're just the general antiderivatives of a function. And one thing that's nice is that since I introduced the notation and that terminology back when we did this in chapter 4, this is largely just going to be review at this point. This is when the book is introducing this notation of the indefinite integral. And then they're also saying it's about the net change theorem. That's just the fundamental theorem of calculus, part 2, saying that if you have a definite integral of a derivative, you get an antiderivative just evaluated at the endpoints and subtracting. So a lot of this is just going to be review and additional practice of our work with integrals, both definite integrals and indefinite integrals. But there are a few new sorts of problems that show up in the homework, and so I wanted to call your attention to those. So you'll have some problems that'll give you a formula, something like this, and ask you to verify that formula. And it's possible to just look at that and say, oh, that looks hard. It's actually not especially hard, but it is a question of being able to translate what are they asking. Here, this is an indefinite integral. So they're saying we want to take an antiderivative of this function. That means I'm thinking of this as the derivative of some function. Now, if they didn't give us the answer and they just asked us to find that, that would actually be a very hard problem at this point. We haven't learned how to do that. We will learn how to do integrals like this in the next section. But this is a little bit complicated because I've got these two functions connected by multiplication, and there's no way for me to simplify that multiplication. But they're not asking us to do that from scratch. They're asking us to verify that that's the answer. So they're essentially telling us, hey, that is f of x. Verify that this is an antiderivative of this. How would I do that? I would just take the derivative of this. Okay? So I would say, if that's my f of x, let's take the derivative of f of x. So that would be the derivative of e to the negative cosine of x plus c. I'm going to take the derivative here. This is going to be chain rule. So it's going to be e to the negative, I'm sorry, I wrote that wrong. The negative sign was supposed to go in front. It was negative e to the cosine of x. I just miscopied it there. Okay, so I'm going to get negative by the constant multiple rule, e to the cosine x, chain rule times the derivative of cosine of x, and then plus the derivative of c would just be 0, because the derivative of any constant is 0. But notice that's negative e to the cosine of x times the derivative of cosine of x is negative sine x. This negative sign and this negative sign will cancel, and so I'm going to get e to the cosine of x times sine of x, which is exactly what the integrand was here. That's all I needed to do. To show that this is the general antiderivative, I needed to show that when I take the derivative, I get this. Okay. So here I've got a similar problem written out for you. What I want to encourage you to do is pause the video, see if you can confirm this formula, and then if you want to check your work, tune back in and we'll work through it together. Welcome back. Okay. So again, if I'm asked to confirm this, we're saying let's think of this as f prime of x. They're not asking me from scratch to come up with an antiderivative. They're asking me to verify that this is an antiderivative. So I just need to take f prime of x, which would be the derivative of 2/3 tangent of x to, tangent of x to the 3/2 plus c. The 3/2 just applies to the tangent of x. Okay, so this is going to be a combination of chain rule with the power rule. So I'm going to bring that 3/2 down. So I've got 2/3 times 3/2 tangent of x to the 1 less power, which would be to the 1/2 power, times the derivative of tangent of x. There's my chain rule. Plus the derivative of c is just 0. But the 2/3 and the 3/2 are going to cancel. tangent of x to the 1/2, that's just the square root of tangent of x, times the derivative of tangent of x is secant squared. Now, when I'm multiplying, the order of multiplication doesn't matter, so I could certainly switch the order. In fact, let's just give myself some space and do that. So I could say that's the same thing as secant squared x root tan x, which is exactly what I had in the integrand right here. Okay. So that's all they're asking you to do with a formula like that, and it's just understanding what this means. This is saying find the general antiderivative, so whatever you find is an antiderivative, which means if you take the derivative, you'll get the function inside the integral sign here.